So welcome students. So in this question, you're given two curves. X is equal to root of y minus 1 and y is equal to x plus 1. You're asked to find the area bounded by these two curves. So first let us try to draw the graphs of these curves. Y is equal to x plus 1 is a very straightforward equation. It's an equation of a straight line with slope 1 and y-intercept is equal to 1. And x is equal to root of y minus 1. This looks slightly problematic. So let us try to draw this step by step. So to do that, let us first look for some basic graphs which are related to this graph. So let us, instead of y minus 1, let me put y. So x is equal to root y. This is a very basic graph. So x equal to root y, this graph is not taught you, but x square is equal to y, that is y is equal to x square is a very familiar graph. So y is equal to x square is a upward parabola which looks like this. This is y is equal to x square. So when y is equal to x square, x will be equal to plus or minus root y. So these two curves are same. So x square is equal to y and x equal to plus or minus root y is same. Now x equal to plus root y represents this half of the graph and x is equal to minus root y represents this half of the graph. So if you have only x is equal to root y, if you want only x is equal to plus root y, the graph will be something like this. Now, what is the difference between this graph and this graph? So this is x is equal to root y is this graph. X is equal to root of y minus 1 is the required graph. So the difference between these two is simply in the place of y, you have y minus 1. In the place of y, you have y minus 1. So what happens? In this case, if you have y minus 1 in the place of y, the graph will just move 1 unit upwards. So x is equal to root of y minus 1 will be the same graph which moves 1 unit upwards. So the graph will be something like this. The same graph will move 1 unit upwards. So we have y minus 1. So if you draw the same graph, if you draw both these graphs in the same figure, so the y is equal to x plus 1 will look like this. So if this moves 1 unit upwards, the 0, 0 becomes 0, 1. So this is the point of intersection. And if you have a parabolic graph, it will have one more point of intersection here. So if you can find these two points of intersections, it's very easy to find this area. So let us first find the point of intersections. We know that this is one point of intersection. We need the second one. So how do you find the point of intersection of these two? We'll substitute one of the variable. We'll try to eliminate one of the variable. So y is equal to x plus 1. So I'll square this. So x square is equal to y minus 1. So x square is equal to y minus 1. And y is equal to x plus 1. So x square is equal to x plus 1 minus 1. So minus 1 plus 1 gets cancelled. X square minus x is equal to 0. X into x minus 1 is equal to 0. So x is equal to 0 or x is equal to 1. That means if you have the point of intersection, the x value will be either equal to 0 or it will be equal to 1. So the x of the point of intersection is 0 and 1. So once you get this, what is the area? So area is nothing but upper curve minus lower curve, you have to integrate. So area is nothing but integration from 0 to 1. Upper curve is y is equal to x plus 1. So x plus 1 minus the lower curve. So what is the lower curve? Lower curve is nothing but, so you have to convert this curve into y is equal to something. So x square is equal to y minus 1. So y is equal to x square plus 1. So this is the actual curve in terms of y. So minus of x square plus 1 dx. So 1 and 1 gets cancelled. So if you integrate this, x integration is x square by 2 minus x square integration is x cube by 3 from 0 to 1. That is equal to 1 by 2 minus 1 by 3. That is equal to 1 by 6. So the area will be equal to 1 by 6 square units. So that's the answer to this question. Thank you.